Hello, all of you. This is Ashish Bajpayee from IIT Kanpur, and today is the Week 5's live session. Uh, okay, let's wait for others to join. Am I audible now? Hello? Can you hear me? Hello? Yeah. Now am I audible? Hmm? Okay, thank you, Kripa. So, So today is week 5's class. So I think some of you have already joined. So you can ask your doubts you were facing from previous sessions or previous weeks. So I will try to cover today some MATLAB coding problems for CFD basically. So starting very simple second order derivative, how to solve it, and how to make grids, how to make 2D grids. So in MATLAB, those things I will cover today. So if you have any problem, you can stop me in between and ask questions. But in the first, yeah, Purv. Hello. Uh, you can unmute yourself and ask question. I can't hear you.
So now can you hear me?
How can you share it? Okay, it's my thing. I don't know what's going on. Something is wrong. I can't hear you. Hello? Now you can hear. I can hear, I think. So, yeah, yeah. Actually, my earphone was creating problem. So, yeah, fine now. Tell me. Hmm. Oh, again. Now it should not be. Hmm. Mm-hmm. Yeah, yeah, you are correct. So I will tell, at least I will tell today how to write at least a simple type of grid, how to make it in MATLAB. So that I will tell today. Thomas, I uploaded a video in week 3 video. So I think you got it that video or not, I don't know. Why? I have uploaded that video on YouTube. No, I didn't uploaded any code for that, but in week three's video, if you see in the last, I told different algorithms, Gauss-Seidel algorithm and but personally, okay, but yeah, last time also I have covered initial like yeah, last time also I covered about MATLAB programming. I think in the fourth week, I think fourth week's video I covered. Hmm. Yeah. So, but I have to start from some point. Everybody is not will not understand, and I can't cover everything in one class. That's for sure. So everybody was complaining about that, but how can I complete everything in one class? Hmm. So yeah, in this week and next week's live class, you will at least understand the like how to solve diffusion equation and second order derivative and how to make grids in MATLAB. So I think I have to go step by step because some of you will again complain me about starting from very high level. They will say that you just started from high level. We don't understand how to discretize even the grid. So then what should I do? Like I have to do it because like if you understand this, which I will teach today, then I think you will be able to make grids at least. I will show you some commands in the MATLAB and yeah, something I think I will teach today in which I will guide you to make 2D grid, 1D grid, and in week fourth assignment is dates over. Date is over. But week five's assignment date is when? This 30. This 30. Okay. Uh, so one more thing I want to ask: are you getting these notes which I am teaching in these lectures, you are getting. So can I write in those notes and upload it? Okay, but I am assuring you, I am saying this one thing, that for regarding assignment I can't teach anything, and I can't upload anything. Yeah, so that's a policy. So I will teach, like, whatever the things are required for that, I will most like I will try to prepare that. But today focus on this, because you like I will start from very simple problem, but that's very important to you to understand for next step. So yeah, today I will cover steady state equation, but if you don't understand this steady state equation, you will not understand the time marching. So yeah, this is very important today. Try to listen and try to observe the code, and this video will be provided. You try and write that code by yourself, and next week, before that, I think I will upload in notes. Yeah, that's a good idea. In notes I can share something. No, I will upload in my notes section. In that folder, you can see, because in discussion forum, sharing these things would not be possible for me. So better to better to see in my notes section. I will upload something or other, some codes maybe I will share. Okay. So is it fine with everybody? Because like I was getting lot of complaints about not supporting, but how can I support? I just have one class in the week, and in that I have, like, last time though I was not well, but last time I covered like a good step about MATLAB. Like some of you don't even know how to write matrix in MATLAB, so I have to cover that. So that is why I am not saying that someone is wrong or what, but yes, I have to start from basics. But yeah, no, actually, this is not in my control. This all the things will come from NPTEL team. I have to take the class as per they said. Yeah, I can't. I don't have. I am just a student in IIT Kanpur, PhD student, and because I am PMRF, I am taking this class. Okay, so there is a duty, live class duty. That is why I am taking. So I don't have any control over that timing. Yeah. Mm-hmm. That will be fine. Now I am getting your idea. That I can do it. Uh, Before your assignment submission, I will do. But for coding purposes, don't be afraid by coding, and start writing some code. So today, whatever I will cover, you try and implement it. So there will be some plotting section also. Yes. In assignment 5, I think there is a plot required also. Let me see what's the assignment 5. Uh, but if you know the Cartesian grid, then only you can go for curvilinear and trigonal. So this is week 5, no? Uh, okay. Mm, this is your assignment. Okay, you can't see the screen. Okay. Just a second. Just a second. Something is wrong with my system. I'm trying to share, but it's not. Okay. Just wait for 2 minutes. You were the one who sent that 00 some link that in this video I am not getting. Okay. Some but yeah, you sent it. Yeah, there like it was not a time. So how can I do it? Yeah, some typo and they send me. So I have limited time for this. So like you have to be careful. Some problem is going on in my system. Just a second. Uh, can you share my? Can you see my screen? Are, okay. This is the assignment you have given. Bye, sir. So today, maybe this in the not curvilinear section, but this type of equation solution I will cover in my lecture. And to which permit the check of accuracy of computational solution. Yeah, it will cover the accuracy. Code provided instead. Code is provided to you. Hello. Fortran code is up. Okay, sir. Provided Fortran code, not MATLAB code. Okay. So yeah. So do you want me to cover it in Fortran or MATLAB? Okay. Okay. So let me start. Okay. So that it will be covered today. So I will cover some basic steps. So be patient and because it is necessary. So this is the problem. For first, I will start with 1D equation. Okay. Then is next step is 2D equation. So you will get to know. So this is the equation: d square y over dx square or del square y over del x square is equal to 0. This is the equation which is the theoretical equation which I am going to solve today. Okay, so there is a rod of, you can say, y left corner is at 0 degree temperature or anything, and y right corner, this is the right one, which is at 1. So we have to solve for at different point for what will be the temperature, or here it can be anything, but right now I am moving towards temperature because in the next 2D problem the domain will be like this, and we will make Cartesian grids, or you can say this type of grid, and then we will solve at this point the temperature is something, at all the other point temperature is 0. So how this temperature will vary? How should it vary? This should vary like this. And but how can we make the grids and discretize the domain and then solve the equation by writing code? And this will be by checking the errors in a for loop. So let's integrate this equation. I am writing full because I will share these notes, so you will understand. dy over dx is equal to 0. Oh, sorry, not 0. It will be some k1 or c1, and again if we integrate, that y will be k1x plus k2. So this is y if we call, okay. But suppose we need to discretize it, d square y over d square. If we want to discretize it, how will we discretize it? It will be by center difference scheme. We can discretize it like this. And here h is what? H is the discretized grid size, okay. So suppose one point is I here in this rod. I am taking one point as I, so this neighboring point will be I plus 1 and previous point will be I minus 1, okay. So I am taking this points. So how can I conceptualize the grid here? Conceptualizing the grid is like this. This is the, let me make it. This is some, I have divided it into the 4 parts. So 1, 2, 3, 4. So this is the first part, second, third, fourth, fifth. So one more thing you need to remember is that in if you are coding in MATLAB, so it will start from 1. The array indexing will start from 1. Or matrix indexing will start from 1 comma 1, not from 0 comma 0. So if you code it in another language, it will start some, like suppose you code it in C, so there it will start from 0 array indexing. So there you can say that this is 0, 1, 2, 3, 4. But in this, for convenience, I am taking that this is starting from 1 and from left to right. And so if suppose I is equal to 2 is there at this point, I want to see the variation, then d square y over dx square what will be what? Y I is equal to 2 means y3 minus y2 plus y1 by h square is equal to 0. So here if we calculate this y2 will be what? 1 by 2 y1 plus y3 means, what does this signifies? This signifies that y2 value at y2, or suppose the temperature variation we are seeing in a rod was, then T2 will be the average of T1 and T3. Similarly, T3 will be the average of T2 and T4, means the neighboring points average will be there, and this is what I have written here. But if we want to write it in a generalized form, what will I write? Y at I, means y at 2 suppose, will be the average of the next point, which is yi plus 1 plus previous point yi minus 1, and this is the average quantity. So yeah, this one. So this is our result which we got for generalized you can say equation. So let's see in MATLAB how will we define. First thing is to define a problem, what are the things we need. First thing is how many points are there. So any problem you want to define, so how many points will be there in that. Let me write this, that yi is equal to half yi plus 1 minus yi minus 1. In this, if you are getting problem or not understanding, it's fine, you can ask me. I am going a bit faster here so that I can cover code. First thing is how many points are there, means what will be the value of h. H is the discretization, like number of points, how many you will in how many points you will discretize it. Second point is defining the boundary condition. Boundary conditions. So here in this, suppose you need to define it. How will you define? So we have discretized it into the 4 part. So here what will be the value? Here what will be the value? These are the boundary value. First we need to define it. Then only we can go further. So here I have defined that y is equal to 0 at L is equal to at L. Hello? And y is equal to 1 at L R at the rightmost point. Fine. So let's define y1 is equal to 0 and y at 5 is equal to 1. And then these are the things when we define. Then third point is then initialize the problem. Initialize the problem means we have to take some values at these points also. Like what's the point? What's the value at of y3, y2, and y4? What is their value? Then we can take their average, and then we can move further. Then we can solve the equation. So we have to assign some initial values, and one advantage we will get with MATLAB is there it will initialize automatically with 0 sometimes. So these are 3 points, and then we need to use the discretized form of equation, means the algebraic equation, to solve that. So then use the governing equation. Which is this? Fine. So let's suppose we have created y1 is equal to 0. So new value, and we will use our old values as for calculation, not new value. This you will understand now what I am saying. New value of y3, suppose I am get is average. So I have taken y2, y3, y4 as 0. y2, y3 and y4 value as 0, so that I can move further. These are the initial value, as I said here, initialize the problem. I have taken y1 as 0, y5 as 1, which are the boundary conditions, and I have initialized the problem with 0 values, and I have taken like 5 points, four sections in that rod. So this is the discretization, and then I have used the discretized form of the governing equation. Then I am calculating new value of y3. First thing is y3, because right now I don't want to use boundary conditions, that's why. So average of the values, two and y4. y3 means y2 and y4 average will be there. So y1 is 0, y5 is 1, y2 is equal to y3 is equal to y4 is equal to 0. Then y2 new value, so this is the superscript, y2 new is equal to half y3 plus y1. This is clear. And y3's value is what? 0. y1's values is what? 0. Okay. So 0 plus 0 half is actually 0. This is y2 new. But when I calculate y3 new, I will not use the new value. So there are two strategies. One is to use this new value and then move further. One is to use the older values. And when you use the older value, it will be bit more iterative, but when you use a new value, it will be less iterative. But right now I am taking the long way, and I am taking the average values or from the previous, or you can say the older values only. Then half y4 plus y2, and I am not using y2 new here. This is the point I want to say. And what is that? It is half, again 0 plus 0 is equal to 0. So this will continue for long, and then you will calculate the values and it will come to new values, and then you will see the values at different points. So this is the iterations. And the third point is, the first thing is you have defined the problem, then you use the discretized values and how to calculate it, discretized equation and how to calculate it, the values, and then how to calculate error. This is the 3 points of coding, or 2 loops of coding. So first thing is initialize with some values, then make a loop in which you will calculate the values at different points by like not taking the new values, and then you will calculate the error. And from that error, we will see that if this error is coming in the range, then only we can move further for the end of our simulation or end of our code. Okay. Error will be what? Is the summation of y new minus y old. So I am not writing old. And if y should be less than, this error should be less than tolerance limit. And tolerance limit is something which I will clear in the code, means something like 10 to the power minus 7 is the error which we can neglect. So then we can stop our algorithm. Hope this is clear for everyone. And this is algorithm is clear. Now let's move for coding. So this is the MATLAB interface. I am saving this as diffusion or sorry, second order derivative. So first thing is one more thing I want to say to you guys, that whenever you approach a problem in assignments or anywhere, the assignments is just basic thing. Here sir has already given the code, but as you approach a problem, first thing is to make a algorithm like I made this time, and then you will connect it with code. So code is nothing but the algorithm, just applied with some parts or some syntax. So main thing is algorithm. If you understand the algorithm, then you can make it in the code form, and then you can compute it in for loop and all. So I suggest you to take small values. Suppose right now I have just discretized it in a 5 points. I could have discretized it in a 50 points, 100 points, but there understanding the algorithm will be very difficult. But as soon as I discretize it in a less sections, then it will be easy for me to guess the values and make the algorithm. So this will be handy for you guys when you apply it. And algorithm making will be the first part. As soon as you make algorithm, you can do it in any programming language. Suppose sir has given it in a Fortran code. I don't know what to do with Fortran code because I am not aware what he has given, but I will see and I will let you know. There you can run it with G Fortran in your compiler, and then see what are the steps he has taken in that code, so that you will understand. And here right now we have one more thing like ChatGPT. So you upload that code to ChatGPT and ask it to understand, like explain you the algorithm. This is not illegal. You can do it and then understand what are the algorithms sir has applied in that, and then you can easily make sure that like I can do it with this MATLAB code by making this type of curvilinear grid. You can do it with ChatGPT. It is absolutely fine, and you can ask it to make you understand that point, like what's going on in that code. So that's the algorithm which it shares. Anybody have question? Nobody? Fine. Yeah, you are correct. But right now, first, this is the first code, so let's do it with that simple one. You can do it. It's fine. And I will also in the next section, I think in the next code. So two codes I will explain today. One is for as I explained already. One is for 1D, one is for 2D. So this is for 1D, and then we will move for this type of equation in which del square x it is a function of x and y both, means a plate will be there and we will solve for plate. Right now we are solving for rod. Fifth week, there is no scenes any question. So Purv, am I clear? Excuse me. Okay. So Yash is asking that in assignment fifth week there is no scenes any questions what we have to submit in the assignment file. So that is the you have to share your code, I think. Along with that, you have to share the code's result and scan it and send it to us. Most probably that will be the case. I actually don't know, Yash. I'm sorry about it, but I don't know what to submit in that fifth week assignment. Because I have not seen the assignment and I have not. I think it's the results you have to share in a file, like Word file. You can share. The code sir has already given, I think. Okay, you can share if it is written there. Yes, yeah, I think what Apurv is saying is correct. If you have written a code and you got results from that code, then you have to submit it. Another part is so I actually don't know what to do in that assignment 5 and what to submit, but yes, as far as I am getting is you have to share the results. Along with that, you have to share the code if you have written that. Fine. If I get to know something, then what I will do is I will write in my notes. This much I can do. Yeah, fine. Okay. Let's do the code first. Then you can ask me more question. So first point is like we will divide it section wise. First is a clear section. So as we always do is clear all, close all, and CLC. These are the three sections. These are the 3 points we have to write first, and then in algorithm we understood first point is what to define the problem. So let's write the define the problem section. How will we define the problem for MATLAB? So or we can define the mesh defining. So this is for 1D. So number of points first I need to define. So I think everybody knows about variables. So in variables, don't define like and space points. So we use underscore here, and sometimes you can use this n points, this kind of way. So but there should not be a gap. Oh. Okay. Okay, I have not covered more, so it's fine. Now, can you see my MATLAB screen? So what I have explained is, first you need to make a clear section. So I do it mostly in the section wise manner in MATLAB. So if you go section wise, then it will be very easy for you to debug it. If something is wrong with code, then it is easy to debug. So I suggest to go with in this manner. So here first section I have written about clear all, close all, and CLC means clear the screen. Okay, then what is the first thing we have done in our algorithm definition is define the problem. We have to define the problem in which we will initialize and define the boundary conditions. So for that we need to define the mesh basically, and in mesh we have to define the number of points of mesh, how many number of points you will take in that domain. So what I was telling is, if you are defining the variables, you define like this, n underscore points, and you can define like n space points. So it is wrong way of defining the variables, or you can say, yeah, variables only. There is another way, n small and capital P and point. So these are the some ways. You can't start with some letters, so that will be wrong, and it will interpret it wrong. Code will stop there. So variable defining in coding is a must. So we have defined it 5 points, okay, in the problem as I shared. Okay, how can I show you that? Okay, you need to see also. Sorry. Okay, fine. Let me first do it. Okay, domain size. So I will define domain size as dom underscore size. So this is my variable I have defined, which is I am taking as 1 because it is non-dimensionalized. So whole domain I am taking as 1. L length of the domain I am taking as 1, and number of point on that domain are 5. So if, let me see that I can do some whiteboard thing. Yeah. You can see the screen. Sorry for, just confirm it. Yeah, fine. So you need to define the h. H is the discretization of the domain. H, what will be h? H will be the domain size divided by number of points. Okay, in how many sections you are dividing it. So that will be h, and h is number of points. But this is not correct. We have defined 5 points, but we have discretized it into the 4 sections. And when we divide the domain size by 4, then it will be h. So that is where algorithm comes in handy. So this section I have defined. So I have defined my problem now. Then now I have to make another section in which I will initialize the problem, and in initializing what boundary conditions I have defined is y. So let me run this section. Okay, run section. So you can do control enter. Okay, so we have defined I think there is some problem. Why I can't run this section wise? Oh, why it is going to enter? Fine. I think there is some problem in running section wise. Okay, fine, but I have defined like these 2 sections have run, and in these 2 sections you can see number of points, n points it has taken as 5, h it has taken as 0.25, means domain size is 1, divide by 4, which will be 0.25, and domain size is 1. These are the three things. Then I will just a second. Okay, so then let's define y1, which is 0. Y1 as I defined it in algorithm. Then y for last point, but we have to do our code as generalized code. So last point is n points, means fifth point, and if I take it as 50, then it will again take this is the last point as 50, and the last point boundary condition we have defined as y at fifth point is 1. Okay, so this let me write the comment. So you can write your comment by this here, and this comes in handy when you again see the code. Then y underscore new, a new variable I have defined, which is at 1, which is again 0, and y underscore new at n underscore points is equal to 1. Error. So error, as I explained, there will be one error section. So error magnitude is 1. Magnitude I have taken 1, but error required. So in the starting I have taken error magnitude as 1, but we have to go to 1e minus 7. So this should be the reduction in the error. We will see in how many iteration it will reduce the error requirement. Or so I will define another variable named iterations is equal to 0, means there is no iterations, and I have to see in how many iteration it will cover, or it will converge my solution. Converge means it comes to the error requirement from error magnitude. Okay, so another section is, now comes the calculation, for which I have already taken the equation, which is the neighboring points average. Okay, so I will use the while loop here. Why I am using while loop? Because I have to run my loop till the error is reduced to error required, means this magnitude 1 is reduced to 10 to the power minus 7. Till then I have to run my code. So error underscore magnitude, if it is greater than error required, means error, if this magnitude whichever I will complete calculate in my loop, if it is greater than error required, then run the loop. If it is less than, then come out from the loop. This is the concept which I am applying, or you can say algorithm which I am applying. Then I will apply a for loop inside the while loop, in which I will calculate for every point. Again and again I will compute for every point the value of y. So I is equal to 2. So here how to define for loop is, you define any value I, which will run from second, means y2 to y2 2, means range of that, from where to where it will n points. N points means number of points, means 2 to 4 it should run, not 5. 5 point we have already defined, n5 at n point will be 1, means the boundary condition we have also already defined. So it will run for 2, 3, 4. 3 points it will run. I hope you are getting it, and if you are not, then please ask me in between. So what we have calculated is y new we have calculated for y 3 new, y2 new we calculated. And how we have calculated is we multiplied 1 by 2 means 0.5. And last time I have already explained that if you directly multiply, it will multiply it in a matrix way. But if you add this point, then it will like zero point 0.5 will be multiplied by each point of, or each value of the matrix. Okay, so what is that? Y I plus 1 plus, yeah, it is very simple, plus y I minus 1, sorry, I minus 1. So this is the y new, as I discussed in the algorithm. But here I am applying a loop for 2 3 4 point. 3 point it will go again and again, and as soon as my error is reduced, it will converge the solution. Okay, then as soon as my y is increased from 2 to 3, my iteration means how many time I have run the code, then iteration will increase by 1. So iteration will be iteration plus 1. This and then I will end this for loop. For loop will end. Now I will calculate calculation of error is required, as I told in the algorithm. Calculation of error magnitude, fine. And for that also I need to apply a for loop, and for each point I have to calculate it. So error magnitude is, suppose again I will define error magnitude here. So this I will explain later. Yeah, for, and similar for loop I will apply. So again sum I is equal to 2 to number of point. For every point I need to calculate the error, and endpoints minus 1. So this is again the same range. Then error magnitude is equal to error magnitude plus what? Absolute of y, the difference between that, yi new minus y. So this is absolute, so I can write anything, yi or y new I previous. So yeah, y new. Okay, I have calculated y new here and yi is there. Okay, fine. But yeah, y new I. Okay, fine. Then I will end this for loop again, and then I will assign this new to old value, means y is equal to new y is equal to y underscore new, and yeah, new. Then I will end the while loop. So this whole loop will end, and here inside this loop I will have applied 2 loops which will go on. You will understand it. So let's run it. I have written the code, and if you have any problem you can ask me. I'm going to run it and see what are the values coming. So error required is coming here, and iterations are 3. So it has calculated for 3 values. Okay, there is some mistake I have. This must not exceed 1. So I have also made some mistake. Let's see what's the mistake. It is giving index number of error in second derivative line 30. It will give you line. Okay, what's the problem? Let me see what's the problem. There is something wrong in that. By I plus 1, I have written it. Okay, and points minus 1. Error magnitude is equal to error magnitude. What's the problem? I know. Okay, let's wait for 2 minutes. It is also creating problem by running section wise. It is, yeah, why is still required. There is some very small problem pre-initializing for I is equal to 2 to n points minus 1. Y underscore mu of I. Okay, let me stop it. And so this is the debugging part which anybody can do. So iterations 3, 5. I think I make some problem. H is correct. Can you guys see the problem? So who shared this Jambo? Okay, sorry. I have written this code. Let me see where I have written, where I'm making mistake. I don't know what MATLAB problem or what. 510. Yeah. Oh, this is the problem I have done. Why new I have not defined, and it created this much mess. Yeah, now I am getting it. Sorry for the mistake. So this small mistake can take you so much to lot of trouble. So I have not defined the y new as I, means as not, it is not defined as array, and it was defined just a variable. So that is the reason I was getting the error. I was not getting the values for this. So now it has iterated these values for 114 times. So you can see for iterations we have run for 114, and y have defined, means y values are defined as 0, 0.5, 0.25, zero point 0.5 and 0.75 and 1. So these are the 5 points values we got. And yeah, suppose this, let me stop. So this is the code I have written for 1D, and here we are getting these y new values for different sections after 114 iteration. So let's plot it, then you can ask me question. So let me cover the plotting part. So in plotting, I will define one thing, y x domain as 1 to n points. Sorry. And then I will multiply it by h. So these are the x domain points, and then I will open a figure. So in MATLAB you open figure like this, then plot it like x underscore domain comma y, and y this. Okay, this value we will get, and for at which x you are getting which y, this will plot it. Okay, so let's plot it and then see. So it is giving me linear values at different from 0 to 1. the at whatever point you see, the value will be same. Means at 0.25 the value will be 0.25. So this linear variation it is giving me. Yeah. So now anybody has doubt in this code? I know that there is some problem in between, but now the code is fine. Yeah, you can see and you can take it, you can write on your own and then see. Ask me question and then I will go for 2D code. Anybody there? Okay, you understood? Okay, like it is following the algorithm and you have to follow the algorithm. So this is the basics for like applying for suppose you have to apply for 2D, then in the for loop there will be another concatenated for loop inside that for loop, so that for x and y direction, and is 3 dimensions you need to apply, then there will be 3 for loops, one inside the other. So you need to go from I is equal to 0 or I is equal to 1 to I and then j is equal to 0 to j and k is equal to 0 to k and for making the grid there is a function which I will tell now. So others can ask me question. I want you to guys to ask question in the simple code or you just say that you understood, because you are asking questions that you are not able to get the like bigger codes. So this is the very initial code for 1D problem. You should get it, and if you are getting any problem in this, then you understand, you should ask me question, then only I can go for next one. These are all steady state equations. There is no time involved, but as soon as I introduce the time, then it will be a time marching problem and it will be a bit difficult. Okay, nobody is asking. Fine, I will go for 2D now. Stop presenting here and start presenting here. So these are the steps we followed. I will share this. Now comes another problem. Let's see what's the problem. Now we will consider a 2D steady state equation. What will be that equation for a plate? So this will be 2D diffusion equation, and let's solve it by MATLAB code. Okay, the first thing is to define the okay, just a second. Yeah, 2D diffusion equation. And what is a 2D diffusion equation? If I say my temperature, now I'm directly taking the temperature, is a function of x and y, or let's say temperature depends upon x and y, then what will be my partial differential equation will be d square t over d square dx square, d square t over dy square plus is equal to 0. This is my partial differential equation, and I have defined x as this, y as this, and domain as this, okay, and t at any point x comma y. So t is 0 at all the other boundaries. So let me start by describing the boundary conditions, and t is at t is 1 here. So I am taking a non-dimensional temperature. You should understand the non-dimensionality because sometimes we use it here. Like as soon as you get the results, you can change that by your temperature, whichever you are having. Suppose you are having 273 Kelvin temperature here, and you got the results. In the result, you multiply it by 273, the temperature result, and you will get the actual temperature. Fine. So this is what will we do is you have this domain. We will define now in 4 section. Again I will cut. Similar way, but it was a rod and I am taking a. So how will you define it? Suppose this is I comma j. What will be this? I plus 1 comma j. Okay, I am increasing a index in x direction, so I am increasing the in x direction. And what will be this? I comma j plus 1 means j is increasing. Okay, then this will be what? I comma j minus 1, and this will be I minus 1 comma j. These induction one should understand. And then okay, h is equal to delta x, that's absolutely fine, and here h is equal to delta y, that's also fine. In this direction, hy, hx, there are two discretizations. Then what was our del square t over del x square? Ti plus 1 minus 2ti plus ti minus 1 by h square. This was our. If you are changing x, then y should be same. Okay, so this is the partial differentiation. So partial derivatives, what will happen if you are writing this del square t, then y will remain same. So then you can write ti plus 1 minus 2ti. So this I am writing because I plus 1 comma j, so j will remain same, and ti minus 1 comma j. So I am moving in this direction, x direction only, and I am writing for that by delta x square. So hx is delta x, so I am writing delta x square. And then again I will write for, suppose by this pen, d square t over dy square. Now what will remain constant in this is x. X is remain constant. X will remain constant in these three sections. Okay, and in this, so what will I write is ti, I is remains constant, then j plus 1 minus 2t I comma j means the center point for which, oh sorry, this is plus, and now plus t I is again constant, j minus 1 by delta y square. I hope everybody is getting it. So this is how we do discretization of this equation. We have done by simple method, in which simple means very common method, in which we have discretized it by partial differential way by central difference scheme. And now for finding this equation, what will we do? We can add it. Okay, after adding, what will we get is d square t over dx square plus d square t over dy square is equal to ti plus 1 comma j minus 2ti j. Okay, I have written j now. Yes. Okay, plus ti minus 1 comma j by delta x square plus ti j plus 1 minus 2ti j plus ti j minus 1 by delta y square. In this step there are no problems. If you have, you can ask me. Okay. Okay, fine, let me do it. So now I am taking a assumption. What is the assumption is I am taking grid as a square grid. So for simplification I am taking it because for our this code I tried to write it by this way because this will be our first step, and this way you can easily compare with previous section, previous 1D code. So 1D code delta x delta y was not there, but here delta y is also there, but I am taking that delta y as simple in a simple way and same as delta x. So then what will happen, the result is equal to 0. Okay, this is our equation. D square t over t dx square plus d square t over dx is equal to 0. We have discretized it. Again it will be equal to 0 and delta x is taken as delta y. Then what will be the final result is minus 4 tij plus ti minus 1 comma j plus ti j plus 1 plus ti j minus 1 is equal to 0. Because delta x is equal to delta y, they will go into 0, multiply with 0. Then what will be the tij? Tij will be equal to ti 1 by 4 of ti plus 1 comma j plus ti minus 1 comma j plus ti j plus 1 plus ti j minus 1. And what is this? These are the 4 points near to this point for which we are calculating. Means for this ti comma j we are calculating, and it is the average of these 4 points nearby to that. So 4 neighboring point average is that similar to the 1D. So we have calculated it. Ti means the temperature at ij is the quarter of, or you can say average of 4 points near to neighboring points, like four neighboring points of that. Okay. So So for our code, what we need to do is initialize the problem. Plus boundary condition. So in your code also for assignments, these are the things you need to do. Any of the CFD problem is like that. So for temperature at this point or this time, I can write as Tn or T old, and when I am writing T new, I need to write Tn plus 1 for the next point. Okay. Okay. One more time I want to say that you need to ask question, then fine, you can ask. Fine, nobody. Okay, you understood? That's good. let's write code. Okay, directly I'm going. So if you can see the screen, you tell me. MATLAB not visible. MATLAB screen is not visible. Oh, okay, okay. Again, like I have to do it. I stopped it. Share the screen. So now I am opening a new script and saving it like diffusion equation in two-dimensional. Okay, so this is my new script. Let's define first section. Section 1 is clear means clear all, clear close all. It will close all the variables and then clear the screen. Then what was our first point is define the problem. It define the problem. It is similar to that, or you can say mesh. So it was the same here. Oh, someone's mic is open. Please stop it. Okay, now everybody is mute. So here also we have defined the problem first, means the mesh first. So here also I will define same for 2D. So number of points, again here I have to define the number of points as 5. So I can take different, but right now I am taking 5 only. Then again the domain size is total as 1 I am defining. As non-dimensional way I have defined in that previous. So similar way I am going. Then h is delta x or delta y. Here we are taking it same. So it will be domain size divided by what? Number of points. Yeah, minus 1 means in the fourth section. Y minus. Okay, so suppose so in previous section you have understood or not? Here also you didn't. Okay, so there are 5 points and but okay, let me, I have to share the screen again to explain this. So this is the domain. You have divided into the 4 part. 1, 2, 3, 4. These 4 part you have divided. But the number of points are 1, 2, 3, 4, 5. Okay. So you have, if you want to define the h here, h is this, or delta x, delta y, anything. So what will you do? Domain size is 1. So what should I do? Like I want to get h. So what should I do is I should divide. I want to get h. So I should define the domain size 1 divided by how many sections should I divide? 4. Okay. So number of points, but number of points are 5. So I will do 5 minus 1. It will always be. Okay. So, okay. Now you got it? Okay, fine. Thank you for asking. You can ask question as much as you can. Let me share it. So now my MATLAB screen is visible, I think. So we have defined the S now. Now comes the initialization of the problem. Now, one more thing you need to understand is, now we need to define the array in 2D array way. Means we have n points, and again we have n points. Means the matrix is 2D now because I have I and j both. So for y also I need to define I and j, number of points, as 5, 5. Means 5, 5 matrix will be defined here. And what will be that? Like values are 0 here totally. So I will explain this by running it. So all the things are clear, and y is 5 into 5 matrix where every value is 0 now. I have initialized every value as 0. Fine. Then for the first column, first row, and all the whole first column, I will define the value as 1. Means all the elements in the first row as 1, and then y new I have to define. So it will be again a 2D matrix. So n points. So we will get it totally. Y new also same, which is I have defined as 0 again, and y underscore new as first column as 1 again. Okay, then one more thing I need to define as same as previous code, error magnitude, which I will define always as 1. Error required is what? Required is 1e minus 6, suppose I have defined minus 6, 10 to the power minus 6. Then iteration variable is starting with 0. So this initialization is done now. Now comes the calculation part. Calculation, as I told, that it will be the 1/4 of all the neighbor. So let's write it. So it will run while loop again. So this is the format I want to define. Error required should be greater than error magnitude. Till then it will run. So error magnitude, sorry, error magnitude should be greater. Yeah, you are correct. I am right now, I think error magnitude should be greater than the error required. Then we will stop the code, or we will stop the loop. It will run from 2 to I is equal to 2 to which point it should run? Number of points minus 1. Okay. Now comes the section. Till this point it is absolutely same, only we have defined a 2D array, but one more thing is changed. This is the 2D code. So in 2D code I have to go from x is equal to 0, x is equal to 1 to x is equal to n, and then in that only x is equal to, y is equal to 0 to, or y is equal to 1 to y is equal to n. So for again I have to apply a concatenated loop where suppose I have defined a j, and then number of points are same here. If it is different, then I have to define in a different way. And then comes this was something wrong. Yeah, then comes my y new value, which I need to calculate. Y new value is again I am making the same mistake, I comma j I have to define. So 2D matrix y new should be what? 0.25 means 1/4 multiplied with every neighboring point. So let's define it. Y, what will be that? I minus 1 comma j is the first neighboring point. Then y I plus 1 comma j, this is another point. Third point will be y I comma j minus 1, and fourth point will be y I comma j plus 1. I hope everybody is getting this. So this is the main part of the loop, and then I will increase iterations is equal to iterations plus 1. So iteration will increase by 1 so that I can understand the iteration. I will end this for loop and the above for loop, and then now I will calculate the error magnitude. Okay, thank you. You are correct. So calculation of error. So error magnitude, let's take as again like here it will take in as 0, and again I will apply the for loop. So here the similar for loops will follow it. Okay, so here from 2 to n points. So sometimes MATLAB will automatically complete your code, take help of it. So like again a concatenated for loop where I will do it from 2 to n points and underscore points minus 1, and then comes the part of calculation. Here also error magnitude is calculated. Error magnitude is equal to error magnitude plus absolute of the difference between new value and old value. So absolute is magnitude of y I comma j. I comma j I am calculating plus minus y new which I am calculating I comma j, and then I will end this for loop and again another for loop, and then I have to end my while loop. And how I will end my while loop? Assigning the new to be old. Y new, and now I will end my while loop. Okay, as soon as, so let's run it, then we will plot it. So my everything is run, and in 360 iterations I got the results of number of points. And let's see why y is what are the value of y. So at every point I am getting it 1 1 1 1 1, and it start decreasing from there to 0.4286, 0.52, and this, and at the end it is 0 0 as my boundary conditions are defined. And let's see the y value, it will be same. Okay, so I hope, let's visualize it. What's the need of visualizing? Now you will get it. So why we plot? So let's do the plotting part. In plotting, x domain is defined as 1 to n underscore points minus 1, and everything is multiplied with h. This is similar as previous one. And y domain, now also we have to define y domain. Okay, so what will be this is okay, 1 minus, so it will be the reverse of that. 1 comma n points. I think this will be a bit difficult to understand, but yeah, you will get it. Let's define. So this is the domains you have defined for x and y. But what are those? These are the points of two rods in x direction and y direction. You have defined. You have not defined a mesh. For meshing, what you have to do is, suppose you are defining x comma y 2 points. Okay, yeah, is equal to. There is a function named mesh grid. If you run it here in MATLAB and define from for which you need to define the mesh grid. So I have defined the x domain comma y domain. So x domain comma y domain, it will create a mesh. It will create a mesh for every point like our matrix, and you can visualize it. And there is another function named contour. I think URF, contour f is equal to x comma. So I want to make a contour to visualize how this temperature is varying from 0 to or 1 to 0. Okay, x comma capital Y, and I have taken a small y as number of point as suppose 14. So for 14 lines it will show me the temperature variation, and I have to define a color bar or color map. I think color bar. So I have already written this color bar. Yeah, color bar. So let's see how it will run and how it is showing the values in the map. Yeah, you can see the variations. So we have defined this point as temperature T is equal to 1 and other points as T is equal to 0. And these are the XY domain. So let's see, we can insert a okay. Something is there to define the mesh. So this is the mesh in x and y direction. Insert. Nothing. Okay, just leave it. In this figure you can see the variation of temperature from T is equal to 1 to T is equal to 0. Let's see, if we have this similar way, if we have the points 100 points, not 5 points I have divided. I have to understand the algorithm, and to apply it I divided into the 5 points so that I can understand that I need to know the 4 sections and everything, and I can hand calculate it. But now let's divide it into the 100 parts, the whole domain into the 100 parts in x and y direction, and then run the code. So it will take some time to run, that's for sure. And let's see how much time it will run. You can see the iteration is increasing. Some 1 lakh iteration is already going on, and it is increasing and increasing. Something is very slow. It will take some time to run. So you can decrease it also. Suppose you want to do it for 50, 10, and iterations will increase accordingly. Exponentially it will increase sometimes. So I don't know why it is not stopping. There are a lot of points. 100 into 100 means 10,000 points it had to solve my code. for 5 point 5 into 5 25 points, it took around 360 iterations. Then I increased that 25 to 10,000. So you can see the variations here. It is increasing. It should stop. Should I reduce the points? So do you understand the computational requirement here? How it is increasing exponentially as soon as I increase the variance. So let me stop it and do it for 10 points only. Okay, for 10 points it has, you can see previously it was so coarse mesh, so it was, the variation was very less, but now you can see the variation is smooth now in this. Let's increase it to 20 points. So this is how you play with CFD code. So you can see the iteration is increasing. As soon as I increase from 10 to 20, it increased to double. Let's wait now. I have terminated it because it will take a lot of time for 100 and 200. Now I got it. So previous for 20, for 10 it take around 14,016 iteration. Now you can see it again smoothens out. As soon as the number of point increase, it again smoothens out, and the temperature variation in the plate for 2D plate. So everybody of you got it. Now you can do 1D and 2D equation solving, partial differential equation, any type of, because this is a very much needed thing. You can see the grid here. Grid is changing as soon as you are iterating it with the more points. Let's do it with 50 points at least. I have already run it. I don't know, with 50 I have it. Let's see. So tell me, have you got it? Okay. Was it fun? So yeah. Purv got it, Shridatta got it, Preeti, you also got it? It's clear. Okay. So as soon as you write another code for your assignment, follow the similar strategy. Defining the algorithm, then take small coarse mesh first. Just solve the problem. Don't go for ideal conditions and all. Take coarse mesh, take very less section, and okay Preeti, thank you. So take very less sections and then solve it by hand, solve it by small code, and then go for more section. Now I think my iterations are still going on, you can see. So I have solved the problem. Now as I increase the number of iterations, a number of points, it will take a lot of time to run, but obviously my solution with is smoothens out. Means suppose in rectangular plate you solve 100 equations. So at 100 points you will get the temperature value. Suppose you solve 1000 points, at 1000 points you will get the temperature values. Suppose you you choose 10,000 points. 10,000 sections means 10,000 into 10,000. At 10 to the power 8 points you will get the value. So it will more smoothens out, more continuous solution every time. Okay, now I will stop my this live session today, and in next session I think I will cover more codes. And one more thing, you were asking about sharing something, some material for assignment. So I will look into the assignment. I will see how to solve it, how code is done, and then I will also share how to like approach it at least. So this, yeah, yeah, yeah. Hmm. Yeah, yeah, you can do it. Absolutely, absolutely. I have defined it in a non-dimensionalized way. So suppose I have a 1 meter rod. For that I have solved. You can solve it for 100-meter rod. It's fine. I got your question. I got your question. Didn't got it. Your question didn't. I didn't got it. I am opening. So actually, this iteration is going on. Let me stop it. Yeah. Like what? Why will you change? Because it, you are writing a code to calculate those values, and now you are saying that you want to change the. So if you want to have a boundary conditions at that particular point, which you know, then you can change it. You can define that as your boundary condition. But I don't think so. Like you should change. Hmm. Hmm. This is not TDMA. Hmm. Let me be clear. So this is not TDMA. You are solving whole matrix. So you are solving it in MATLAB. That's why it is showing it in a matrix way. But if you solve it another way, then it will solve point wise. Okay. So this is not TDMA. Don't be confused. This is very, yeah. Yeah. So that mostly I will share the document. Okay. It's a another loop kind of thing, but yeah, it will take some time to explain. It is not that easy for TDMA. It's a function actually. Yeah, it's a function. But you can search for it. Right now I don't remember, but yeah, because I am not very good with MATLAB. So MATLAB is never, I never used it. Now, right now for letting you like understand, I use Fortran. Okay, for my coding purposes, Fortran, C, C++, Python, everything, but not MATLAB. So that is why I don't remember the function. But yeah, I know how to code in MATLAB, but I don't know these functions and all. So yeah, if I get to know, I will write it. Hmm? No, 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 no. Yeah, sometimes there are functions available, so you can call that function by copy pasting kind of thing, but you have to do it. So there are functions available online, so sometimes we copy it and call it. You can do it. It's fine. But right now, if you are focusing on MATLAB coding, you right now focus on that. Source code, you, as I suggested, you just upload it on ChatGPT. It will explain you what is written on that, the algorithm, basically. So that is the strategy everybody is following right now. You should not be like bogged down by syntax. So just to ignore syntax, upload it on ChatGPT, understand every section, then you will get to know what's written there. You can do it in similar way in MATLAB. Okay. So that's not a wrong thing to do it. So that is why I'm telling. It's fine. Okay, bye all of you. Now I'm stopping. I will upload something in my notes. Okay, Preeti. Okay, bye.